We will continue with our discussion and we'll be talking about mechanical systems. So we previously looked at electrical systems. Mechanical systems are typically things that we often see actually tied to electrical systems. You see, we saw the pump and motor. Um, that combination is pretty typical. This is a motor drive connected to a grinding wheel. You may have a similar sort of system in your garage, perhaps. So here we have a motor. We talked about motors previously, and it's connected to the mechanical load. In this case, our mechanical load is just a grinding wheel, and we have a pulley on the motor, and we have a pulley on the grinding wheel, and it's connected with a belt. So this pulley and belt arrangement is sometimes called a drive system. And there are lots of drive systems as we talk about mechanical systems going forward. We'll talk about all kinds of drive systems, hydraulic drive systems, belt drive systems, chain drive systems, direct drive systems, a lot of different options here. And again, just as we were talking about with the mechanical idea of switches, hundreds of different kinds of drive systems. Each one has particular strengths and particular weaknesses, so picking the right drive system is a really important thing to try to do. Um, then we have a direct drive system. So here we have a motor that's connected with a coupler. So there's no gear, there's no belt, there's no pulley. The motor turns at exactly the same speed as the pump because the two shafts are connected directly. In this case, they're connected by a flexible coupler. Now, if you think about this, we have to always think about, well, what happens in this situation? Because we want to have this thing properly aligned. And particularly if you're in a mechanical discipline, we're going to talk about alignment a lot going forward. But alignment essentially is how the motor aligns with the shaft of the thing it's driving. So if we could imagine that this pump is pumping a cold liquid and the motor is going to be driving that pump, and if the motor and pump are connected perfectly at room temperature, when we start the system, the motor is going to get warm, which is going to cause it to grow a little bit, so it would move up slightly. The pump is going to cool because it's pumping cold water, so it's going to shrink slightly. So we would have a little bit of movement there. This flexible coupling will give us the allowance for that little room, little movement, a little room for margin, if you will, that gives us the flexibility to maintain acceptable alignment between the pump and the motor, even when there's that slight. A pump is just a device that uses kinetic energy to create pressure energy. So what we're going to do here is if we look at this pump is on the left, we see the inlet of the pump. And the inlet of the pump, some fluid is going to come in and it's going to be accelerated by the impeller, which is the thing that's inside that larger blue section. And that fluid is going to accelerate out of the volute. So when we accelerate something, we're going to increase its velocity. As we increase its velocity, we're going to increase its kinetic energy. As it leaves the impeller and goes into that expanding volute, that kinetic energy is going to be converted into pressure energy. And that's all a pump does. You've heard people say, well, water can't flow uphill. Well, it can't unless we give it some pressure energy, and that's what we use pumps to do. Here's a cutaway of a pump very similar to the one we just looked at. You can see the suction nozzle again on the left. You see the impeller, that's the piece that physically spins. And then we see that volute, that's the expanding area where we go from kinetic energy to pressure energy. To the right, you'll see the bearings and the other elements of the drive system, and all of that just simply supports the shaft and provides it with lubrication and provides the bearings, which provide both physical guidance, in other words, keeping it straight and keeping it from moving, and also provide a reduced friction surface for the shaft to turn on. Lots of different designs. Certainly the centrifugal pump is the most common design. Here's a close coupled one where the pump is physically mounted to the face of the motor, and the impeller is connected directly to the shaft. But there are just as many designs as you can possibly imagine. Here are a couple more. Here we actually have some sort of coupling between each one of them. You can see the motor is on the left on the one at the bottom. The pump is on the right. You see the orange coupling cover, and that coupling cover just simply is there for safety and protection, so you don't have that spinning coupling that could make contact with a person or a piece of equipment. We have the coupling guard that's nicely orange on that one. In the upper right, you see another coupling guard, but this is a pretty typical frame-mounted pump. Here we have the inline pump. In this case, the motor is mounted above the pump. We have suction and discharge to the left and right. In this case, there's no real alignment because the motor and the pump are physically connected, and if one moves, the other one moves, so they have to move together. There are all sorts of sizes, all sorts of types, all sorts of applications. You can see the illustration on the lower right where the pump is large enough. That's essentially as tall as the gentleman standing next to it. Pretty significant pump, and they get much larger, but they can also be literally as small as your hand. Just because the pump is large or small doesn't necessarily mean how much pressure it produces. So pressure and volume are two different aspects of pump sizing. So you can have a really small pump that produces really high pressure, or you can have a really large pump that doesn't actually produce much pressure, but moves a huge amount of fluid. So a lot of different types of pumps. If we have fluid that's moving around, we probably need to control it, and we're going to do that with valves. And there are, just as there are a lot of different types of switches, a lot of different types of motors, a lot of different types of pumps, there are lots of different types of valves. So we're just going to introduce a couple of ideas here. This is a three-way valve. In this sort of arrangement, you have the ability to take one flow source and shift it from one direction to another. We have a four-way valve. This is another kind of specialized valve where you could have two different flow sources where flow could either be mixed or it could be used as a either-or situation. Think of it as like a mixing key. A quarter turn valve. You probably have one of these in your home. Frequently you see them on water lines or gas lines. It's called a quarter turn valve because it goes from fully open to fully closed in a 90-degree or 1/4 of one turn. If the handle is installed properly, you always have to check, sometimes they aren't. If the handle is in line with the pipe, the valve is open. If the handle is perpendicular to the pipe, the valve is closed. These are really good for shutoff purposes. In other words, to stop flow. They don't control flow really well. They're not very good at throttling, but they're very effective at stopping it so that you have good isolation. Several different groups of these types. We have the wafer type here. This is the concentric. We have a disc that's actually in line with the body, or an eccentric, which is where the disc is offset from the body. Both of these are pretty good at shutoff. They're really not all that good at throttling. An eccentric can be used for throttling if you have to. It's not really desirable, but it can work. All sorts of other valve types, linear motion valves that can do on-off control. There are valves that are called plug, or which is really a type of globe valve, and they're really good for control. And we'll look at this globe valve idea here in just a minute. So in a globe valve, we have fluid. In this case, if you pay attention to the lower right corner here, we have fluid entering the valve, and you can see that it enters the valve and it goes underneath the plug. And this is called a globe valve because that plug looks somewhat round. So if the plug is pushed all the way down into the valve seat, fluid can't rise up underneath the seat and go out to the right side of the valve. If the valve plug is pulled away from the seat, fluid can rise up underneath the seat and pass through the valve. And you can see that there's a little black set of arrows that shows you that that flow path. The actuator, which is the thing that moves the stem and in turn moves the plug, moves up and down. And as you can imagine, if the valve is fully closed, that plug is all the way down to the valve seat. If it's fully open, it's pulled up all the way out of the way. The beauty of a globe valve is we can move it up and down. It can be partially blocking that hole. If it's partially blocking it, then we get throttled flow. Globe valves are really effective at throttled flow. Here we have another valve. This is a gate valve. And a gate valve is called gate valve because literally, rather than having that nice round globe, we have a disc and a seat, and it looks like a gate. And when the gate is closed, it's blocking the pipe. There's no flow. These are really good for isolation. They're not very good. They do not throttle well. So we're going to use these typically in on-off applications. We want to be able to have full flow or no flow at all. Here's another example of the gate valve. This is really just an enlargement of what we saw before. Here we see the seat, the gate, that's the green thing. We have the stem, that is the blue, vertical blue line, and we have a hand wheel up at the top, and you see some threads. So when you turn the hand wheel, it has those threads on it that acts like a screw. It pulls the seat, the disc up away from the seat, so now fluid can flow through the pipe. When we turn it the other way, we turn it toward closed, it drives the seat, the disc back into the seat, and now we have block flow, and we have shut off our flow process. So again, two primary valve types, gate valves and globe valves. They're pretty distinctive. You can see the globe valve has sort of a rounded body because it has that globe inside with the above seat, below seat flow, and that's on the right. The gate valve is a narrower valve body because it just simply has that gate that rises internally within it. So once you get used to them, you'll be able to identify a gate or globe valve on site. So there's a fundamental quick overview of valves and valve types, all of which are part of mechanical systems that generally consist of pumps, pipes, and valves.